This lesson will show how to use Desmos to calculate a confidence interval for a population mean with a known population standard deviation. You measure 50 watermelons weights and find they have a mean weight of 38 ounces. Assume the population standard deviation is 9.2 ounces. Based on this, construct a 99% confidence interval for the true population mean watermelon weight. Let's first list all the given information. The sample size n is 50. The sample mean weight is 38 ounces, x bar is 38. The population standard deviation is 9.2 ounces, sigma is 9.2. Now we need to find the z-score that corresponds to the 99% confidence interval indicated by z sub alpha divided by 2, where alpha divided by 2 is the area to the right of the z-score, which looking at the graph on the far right is 0.005 as a decimal. To find the z-score using Desmos, we need the area to the left, which is 0.995. Let's go to Desmos and find the z-score. With the cursor in cell 1, click Show Keypad, click Functions. Under the Distributions menu, click Normal Distribution. Enter a mean of 0, standard deviation of 1, close parenthesis, either a decimal point or period. Functions, inverse CDF, enter the area to the left of the z-score, which again is 0.995. Let's use the z-score of 2.576. The next step is to use the formula below to determine the error. Once we know the error, we can determine the confidence interval by determining x bar minus e and x bar plus e. The next step is to enter the formula for e into Desmos. In cell 2, we enter e equals z, open parenthesis, let's use s instead of sigma for standard deviation, divided by square root n. Notice we have an option to add sliders for z, s, and n. Click all. And now we enter the z-score, the standard deviation, and the sample size. The z-score is 2.576. The standard deviation is 9.2. And the sample size is 50. Let's close the Desmos keypad and notice how the error to 2 decimal places is 3.35. So going back to our work, to find the lower and upper bounds of the 99% confidence interval, we take the sample mean of 38 and we add and subtract 3.35. Let's go back to Desmos and determine the calculations. Going to cell 6, we enter 38 minus 3.35, which gives us 34.65, and then we have 38 plus 3.35, which gives us 41.35. So the 99% confidence interval for the true population mean watermelon weight is from 34.65 to 41.35. And the units would be ounces. I hope you found this helpful.